Here we're going to talk about special right triangles and how they can be used in the unit circle to find specific trig ratios. So hopefully we have a rough idea of our special right triangles from Math 2. So probably the easier one is our 45, 45, 90 right triangle. And since we have a congruent angle of 45 and 45, then the sides opposite those congruent angles are going to be the same. So the sides opposite 45 are both going to be x, or here in a specific example, maybe both sides could be 5. I'm just kind of coming up with that number 5. Okay, and then the hypotenuse, the side across from 90 degrees, is going to be whatever your leg is times root 2. So x times root 2. In an example down here, if both of my legs were 5, then my hypotenuse is 5 root 2. All right, so that's our 45, 45, 90. Let's move over to 30, 60, 90. In a 30, 60, 90 triangle, then you want to start with the side across from 30, so your smallest side, which is across from your smallest angle. So if we say that the side across 30 degrees is some random variable x, so it could stand for anything, maybe in a specific example, we'll just make it 5. And then, so if the side across from 30 is any x value, then the first relationship says that across from 90, your hypotenuse is going to be double that. So if the side across 30 is x, side across 90 is 2x. So if the side across 30 is 5, then the side across 90 is 10, twice as long. Okay, and then the last relationship in a 30, 60, 90 says that if the side across from 30 is x, then the side across from 60 is that side times root 3. So the short side times root 3 is your side across from 60. So in our example down here, if my shortest side was 5, the side across 30 is 5, then the side across 60 would be 5 root 2. Now what we're going to do is we're going to bring these special right triangles and we're going to bring them into our unit circle. And let's kind of think about that unit circle again. So what do we mean when we said unit circle? Well, what that means is from the center out to any edge is going to be a distance of 1 because the radius is 1. So that means I could put either of these triangles inside this unit circle, and the hypotenuse is going to be 1. So the hypotenuse, this kind of distance right here that's across the 90 degrees, goes from the center of the circle to the edge. So that means that's going to be a distance of 1 if this is a unit circle. So let's check out the 45, 45, 90 triangle that is inside this unit circle here. And so inside the unit circle, that hypotenuse is going to have a distance of 1 if it's in the unit circle. Now, when we look at our general form of the special right triangle right here, well then my hypotenuse is not 1, my hypotenuse is, I guess, x times root 2, or a leg times root 2. But I kind of want this hypotenuse to be 1 so that it will fit perfectly in the unit circle. So essentially what I want to do is I want to take that x root 2, the hypotenuse, and I want to somehow turn it into a value of 1. So that's my goal. How do I get from x root 2 to 1? What kind of change would I have to make? Well, what if I just divide by x root 2? Then I guess x root 2 divided by x root 2 would be 1, and that would work. So if I'm going to scale the hypotenuse down by dividing by x root 2, then in order to be consistent all the way around this triangle, I would have to do the same thing on both of the legs. So let's kind of figure out what each of these legs are going to be. So I'm going to divide the leg by x root 2 as well. Let's go ahead and see what I get here. So my x's will cancel, and I will be left with 1 divided by root 2. And that's a fairly simplified answer, and that's looking pretty good. However, we have this thing where we do not want radicals in the denominator. It kind of comes from old school thinking before we had calculators, but it also helps us to make sure that all of our answers are consistent. So if I'm comparing my answers with another student or the teacher or somebody all across the world, we've all kind of decided that we do not want radicals or the square root thing in the denominator. And so the way that we rationalize the denominator, or get rid of the root in the denominator, is just essentially multiply by 1, but that version of 1 is going to be whatever I'm trying to get rid of. So I want to get rid of the root 2, so I'm going to multiply by root 2 over root 2. So now we have 1 times root 2, which is going to be root 2. And then on the bottom, root 2 times root 2, you might think of it as the square root of 4, which is just 2. And I could do the same exact thing for this left side here because it was the same as the bottom. So let's kind of summarize what we get down here. So now I have a hypotenuse of 1 because that was kind of my goal there, so it would match the unit circle. And as a byproduct, I had to change my 2 legs. So the 2 legs turned into root 2 over 2 and root 2 over 2. So now this is kind of my new 45, 45, 90 triangle, kind of adjusted to fit in the unit circle. Remember, the unit circle has a radius of 1, so the hypotenuse will be 1. So I adjusted my special right triangle to have a hypotenuse of 1 and adjusted the legs as well. So that's kind of my new special right triangle. So now that I have my new adjusted special right triangle specifically for the unit circle with a hypotenuse of 1, then I can use these legs as x and y values because, of course, the unit circle is on my x and y axis right there. Okay, so now let's see if I can figure out this coordinate point, which happens to be in quadrant 2. So this triangle is in quadrant 2, which means I'm going to be moving to the left and up. So when I move to the left, that makes this x value negative. So then my x value is going to be negative root 2 over 2, and my y value is going to be positive because I'm moving up, positive root 2 over 2. And so we could really use this triangle in any of the quadrants. So for example, if I say I had a 45, 45, 90 triangle right here, and just to get experience with one more thing, what if we put the 45, 45, 90 in radians? So 45 degrees in radians would be pi over 4. And so a pi over 4 by pi over 4 by pi over 2 triangle instead of 90 would be the same thing. So that means each of these legs would be root 2 over 2, root 2 over 2. And my hypotenuse, of course, in the unit circle is always going to be 1. And so if I wanted this coordinate point right here, then in quadrant 4, I am moving to the right, which is positive, and down, which is negative. So this coordinate would be positive root 2 over 2. And then going down in the y direction, so a negative root 2 over 2, and that's my x and y value. Here's our 30, 60, 90 general special right triangle. And what we want to do is we want to convert this to be applicable in our unit circle. And in our unit circle, the radius is 1. So we want our hypotenuse to become 1. So I want that hypotenuse of 2x to become 1. So let's think about how I would get there. And to kind of transform a 2x into 1, well, I would divide by 2x, and then I would get that 1. And so, therefore, I have to divide kind of everything the other sides here by 2x as well. So let's go ahead and start with this bottom one. So on the bottom, my x's will cancel, and I will just get 1/2. And let's go ahead and update this bottom triangle here. So I want my hypotenuse to be 1. When my hypotenuse is 1, the side across from the 30 degrees will be 1/2. So that one is done. Let's go ahead and do this left side now. I'm just going to kind of bring my work up here, give myself a little bit of room. Okay, so when I'm doing that left side right here of x root 3 divided by 2x, well, my x's are going to cancel. So that will leave me with root 3 divided by 2. And here I have the radical on top, which is where we want it. So that is all set. We don't have to do anything else with it. So that side across from the 60-degree angle is going to be root 3 over 2. So if I come over to the triangle in the unit circle now, then I'm going to think, okay, well, here is my side across from the 30 degrees, and the side across from the 30 degrees was 1/2, a length of 1/2. So I know that this distance is going to be 1/2. And then the side across from the 60 was root 3 over 2. So then here I have root 3 over 2. So for example, if I wanted to know this coordinate point right here, then the x distance is moving to the left. So I'm going to be moving to the left or in the negative direction, 1/2. And then I'm going to be moving up, so positive in the y direction, and I'm going to be moving up root 3 over 2. And so again, this triangle could be anywhere on the unit circle. And so perhaps let's go ahead and maybe take a look at a situation where I have a 30, 60, 90 down here. And just to get us used to seeing things in degrees and in radians, let's go ahead and write this 30, 60, 90, our new one, in radians. So to convert degrees to radians, notice if I have degrees on top, like the 30 degrees on top, and I want to get rid of degrees, then I'm going to divide by degrees and have degrees on the bottom. So in this case, I'm going to multiply by pi over 180. And we can see that, how about we just cancel those zeros there. So now I have a pi on top, and I'm left with 3 divided by 18. So let's think about 3 divided by 18. Well, that simplifies to 1 over 6. So this is going to simplify to just pi over 6. I'm going a little bit quick here because I'm focusing on the unit circle. And let's go ahead and do the same thing down here with the 60 degrees. So again, my zeros can cancel here. And I will have a pi on top. And then I'm going to be left with a 6 divided by 18. 6 divided by 18. Well, that's going to simplify to 1/3. So that's going to be pi over 3. So my 30-degree angle, the smaller angle, which is this one, is going to be pi over 6, if I can squeeze it in there. And then my other angle is going to be pi over 3. So in this case, instead of a 30, 60, 90, we could call it a pi over 3 and pi over 6, and then the 90 would be a pi over 2. But that's going to follow the same scenario. So my hypotenuse is going to be 1. Okay, let's see, the side across from the small angle, or 30 degrees, is 1/2. So the side across from 30 degrees, the smaller angle, is pi over 6 this time. So the side across from there is going to be a distance of 1/2. And then the side across the 60 degrees, or in this case, the side across from the pi over 3 degrees, is going to be root 3 over 2. So this is root 3 over 2. And of course, these are all distances. And so now, if I want to find the coordinate point where this is in quadrant 4, then I'm going to be moving to the right in the x direction, so a positive 1/2 to the right. And I'm going to be moving down in the y direction, so that's going to be a negative and a negative root 3 over 2. So now we have all the information we need to find exact values of specific trig functions. So here are kind of my two summaries for my 45, 45, 90 in the unit circle and the 30, 60, 90 in the unit circle as well. And these are made perfectly for the unit circle because we have a hypotenuse of 1, and so I can apply these into the unit circle where I will have a radius of 1. Again, the 30, 60, 90 has been converted to a hypotenuse of 1, so I can use that in the unit circle where I will have a radius of 1. and then these x and y values will be found with the legs. So here's our example where I want to find, first of all, the sine of 135 and then the cosine of 135. So 135 is the degree that we're talking about, and that's the first thing I'm going to focus on. So we're always going to start from the positive direction on the x-axis. That's kind of our starting position. And I want to move in a counterclockwise direction, and I want to go 135 degrees. Okay, so let's see. Well, 90 degrees is right there, so I've gone 90 degrees so far. How much further do I need to go? I need to go another 45 degrees. So kind of another half 90, essentially. And that will be the 135 degrees. So I've now traveled 135 degrees. Okay, what I want to do from here is create a triangle. So let's go ahead and create a triangle, and what you want to do is you always want to create a triangle that is touching the x-axis. So for example, if I were to draw a triangle like this, that would be incorrect. That's not going to help me with what I want to do. So that does not touch the x-axis. It doesn't have any legs touching the x-axis. So I'm going to go ahead and erase this. Okay, and then let's get what I want here. So here's my angle coming up here. And I want to draw a triangle that's touching the x-axis. So instead of the one that I just drew, I'm going to draw this triangle right here. And let's think about if this is one of our special right triangles. So if I went 135 degrees, then that is kind of like 90. So let me get my laser here. That's like going 90 right here, and then 45 right here. So what would be left in this little angle right here? Well, I guess that would be 45 degrees. And we can kind of double check to make sure that 135 plus 45 would be 180. And it would be, and which that would make all the way around, halfway around the circle. So I know I'm looking good so far. Okay, and this is a vertical and a horizontal, so that's going to be 90, and that creates another 45 degrees up here. So I now have a 45, 45, 90 triangle. And since this is in the unit circle, I know that my hypotenuse is 1, and so I know I'm going to be using this information right here. And so now that I have all the information, I did all the hard work, and I can essentially just kind of copy this down and say I know that this leg is root 2 over 2, this leg is root 2 over 2. And those are the distances, the lengths. So let's come down here and let's find the sine and the cosine. Now remember that your sine is really your y value, and your cosine is your x value, your x coordinate. So I'm really just kind of finding this coordinate right here. We could even maybe write it out first. So the x direction is moving to the left, so that's negative root 2 over 2. And the y value is moving up, so that's positive root 2 over 2. So my x value is the cosine, so that's going to be a negative root 2 over 2. And then the y value is the sine, so that's going to be a positive moving upwards of root 2 over 2. Okay, another example here. This time I want to find the sine and the cosine of 210 degrees. So I know that I'm going to start from the positive direction on the x-axis and move in a counterclockwise direction, and I want to move 210 degrees. So here is 90 degrees, 180 degrees, and I've done 180 so far. I need to get to 210. So I am going to need to go another about 30 degrees. So somewhere around right there. And again, we want to draw our triangle so that we have a leg that is touching the x-axis. So I'm going to draw my triangle. I know I'm going to have this line, of course. And then I want to draw it so I have a leg that touches the x-axis. So I'm going to go ahead and draw it like this. Okay, and then we said that I went 30 degrees past 180. So that means, I'm going to go ahead and zoom in a little bit. So that means that this is 30 degrees, And then this is 60 degrees, and of course our vertical and horizontal is going to be 60 degrees. Okay, so if this is a unit circle, then my hypotenuse is going to be 1. And now I can go ahead and use my 30, 60, 90 kind of cheat sheet over here and say that, well, what did we know? The side across from 30 is going to be 1/2, so the side across from 30 is 1/2. And then the side across from 60 is going to be √3/2. So the side across from 60 is going to be √3/2. Okay, perhaps we could write it out as a coordinate point here. So what is this coordinate point? What is my x value and my y value? So my x value is moving to the left or in the negative direction, and it's going to be a distance of √3/2. And then my y value is moving down, so that's going to be in the negative direction as well, so down -1/2. And then my sine is my y value, my cosine is my x value. So the cosine, or the x value, and I can just look right there at my x coordinate points, well, that's -√3/2. And then my y value, okay, well, here's my y value right there. That's going to be -1/2. And let's do a final example here. This time we'll go ahead and throw some radians in here. So I want to find the sine and the cosine of 7π/4. So the first thing we need to do is figure out what the heck 7π/4 actually is and where that is as an angle. And there's a couple of different ways we can go about it. Perhaps you want to just convert it to degrees. And you could go, okay, well, 7π/4, I want to convert this to degrees. And you might think, oh man, do I multiply by π/180 or 180/π? I can't remember. Well, remember that the radians has the pi in it, and the degrees does not have a pi in it. So if I want to get to degrees, then I want to get rid of the pi, and I want my pi to cancel. And so if you're wondering, is it 180/π or π/180? Well, in this case, to get my pi to cancel, it would be the 180/π. Okay, and then we could go ahead and simplify that. And that's going to come out to 315 degrees. Okay, 315 degrees. And so optionally, you could just go ahead and kind of change that 7π/4 to 315 degrees and just go about your business from there. A couple other ways to think about this. Well, you might think in radians, well, 7π/4, that converts to 1 3/4 pi. And so if 1 pi is halfway around, 2 pi is all the way around, then 1 3/4 pi is right here. And perhaps even a third way to think about it is we know that π/4 is the same as 45 degrees. So π/4, or maybe you think 1/4 pi. So 1/4 pi, 2/4 pi, 3/4 pi, 4/4, which is 1, right? So 4/4 pi, 5/4, 6/4, and 7/4 pi is going to be right here. So a bunch of different ways to kind of all come to the same conclusion that 7/4 pi, or 315 degrees, is going to land me right there. Okay? And I want to go ahead and draw my triangle so that it is connected with the x-axis. So I'm going to make it right there. And I went 45 degrees, or π/4, past this last mark here, right here. So that means that this is 45 degrees, and also this in my triangle that I'm really concerned with is 45 degrees as well. So you could call it 45 degrees, or you could call it π/4 radians. They're the same thing, just talking about two different systems here. And then you could call this π/2, or just write this little rectangle there to say 90 degrees or π/2. All right, and now I'm just going to be thinking about which triangle cheat sheet am I going to use. Well, this is the 45, 45, 90, which is the same as the π/4, π/4, and π/2 triangle. So I'm going to be using that one. And my hypotenuse is going to be my radius. So my hypotenuse, the radius from the center to the edge of a circle, is going to be a distance of 1. And then my legs in the 45, 45, 90 are root 2 over 2. And those are my distances. And I'm in quadrant 4. So let's go ahead and write out this coordinate point here. So this coordinate point, which is an x value and a y value, is moving to the right in the x direction. So that's going to be a positive root 2 over 2. And down in the y direction, so down or negative root 2 over 2. Okay, so then the sine, well, the sine is my y value, the cosine is my x value. So then the x value that we got, or the cosine, is root 2 over 2. And the sine that we got, or the y value that we got, is negative root 2 over 2.